Now here we have to clearly understand the implications of the assumptions that we are making. In the labor market, wage rate determination is a function of the product market as well as the factor market. The product market demand for in the product market, we talk about the nature of demand being produced by the factor in the labor market. So essentially what we are saying is that when we talk about the labor market, we are talking about the demand for labor and we are talking about the supply of labor. Demand for labor is coming from the firms and the supply of labor is coming from the households. Now let's try and understand as to the nature of demand for labor from the firms. When the firms make demand for labor, in module 5 we already talked about a situation where we are saying that the demand for labor is a function of the MRP/VMP of labor. We have to understand these terms once again for a brief recapitulation. When we talk about the demand for labor, why do firms employ labor? Firms employ labor because of what the labor is producing as well as the demand for what the labor is producing. In other words, what we are saying is that look, the demand for labor is a derived demand. It is derived both from the productivity of labor, also it is derived from the demand for what the labor is producing in helping. So essentially the point which we are making, that demand for labor is a function of the MRP/VMP of labor, the productivity as well as the price at which this output is selling, and this demand for labor is coming from the firms. Now as far as the supply of labor is concerned, supply of labor is coming from the households, and when we talk about the supply of labor, we talk about the supply of labor from the individual households and we talk about the supply of labor from all the households put together, which is the aggregation of the supply curve of the individual households. But here it's important to mention that when we talk about the supply curve of labor, the supply curve of labor for the market as a whole is supposed to be an upward sloping supply curve, indicating that more and more of labor would be supplied only at higher and higher wage rates. But when it comes to the individual supply curve or the supply curve of an individual household, we say that the supply curve of labor for an individual household can be a backward bending supply curve of labor as well. Now why do we talk about a backward bending supply curve? Is because we are saying that there is a trade-off. There is a trade-off between income and leisure. Up to a certain point, with an increase in the wage rate, there will be an increase in the supply of labor effort. Thereafter, when the wage rate goes beyond a certain limit, the supply curve of labor can tend to become backward bending. And this is because our preference for leisure might become stronger than our preference for work, and therefore it can offer us an income leisure trade-off curve which would indicate a backward bending supply curve. But this backward bending supply curve of labor can only be true for an individual household. Aggregation of the supply curve of all the households put together will give us a normal shaped upward sloping supply curve of labor only. So essentially what we are saying is that look, wage rate is determined through the intersection of the demand curve of labor and the supply curve of labor. Now when we talk about the demand curve for labor, we need to talk about the fact that if we assume perfect competition in the product market.
In this module, we will learn how factor price is determined when there is imperfect competition in the product market while the factor market is perfectly competitive, and know how to derive demand and supply of factor. The demand curve for variable factors such as labor is no longer the value of the marginal product of labor, VMPL, when there is imperfect competition in the commodity market and factor market is perfectly competitive. Under the assumption that there is imperfect competition in commodity market and factor market is perfectly competitive. In this module, first we will derive demand for labor in two situations. One, when labor is sole variable factor, and two, when there exist several factors, and secondly, we determine equilibrium level factor input and factor price through the interaction between market demand and supply of factor input. Demand for factor input by monopolistic firm in case of single variable factor labor. In an imperfectly competitive product market, that is, existence of monopoly, monopolist competition, or oligopoly, an individual firm will hire labor up to the level at which its profit is maximized. That is, marginal revenue productivity of labor equals to marginal cost of labor wage rate, provided that there is perfect competition in the labor market. The derivation of a firm's profit maximization is given as, let us consider a production function y is equal to f L k bar. The total cost of production consists of the total variable cost W bar into L and fixed cost F. That is, total cost is equal to W bar into L plus F. Assume that the market demand function faced by the firm is given as P subscript y equals Py. The total revenue of the firm is TR is equal to Py into F L k bar. Hence, the profit function can be written as pi is equal to total revenue minus total cost, which can be further written as pi is equal to Py into F L k bar minus W bar into L plus F. In order to satisfy the first order condition of profit maximization with respect to the variable labor, we set d pi by dl equal to py into dy by dl plus y into dpy by dl minus w bar is equal to 0. That is, py into dy by dl plus y into dpy by dy into dy by dl equal to w bar. This can be further written as py plus y into dpy by dy whole into dy by dl equals to w bar. From the equation py plus y into dpy by dy whole into dy by dl equals to w bar, we can derive marginal revenue into marginal product of labor, that is equal to W bar, where Py plus Y into dPy by dy is marginal revenue and dy by dl is marginal product of labor and W bar is marginal cost of labor. Hence, marginal revenue productivity of labor is equal to wage rate W bar. That is, profit is maximized at the level of labor at which the marginal revenue productivity of labor equals marginal cost of labor or wage rate. Thus, we obtain the demand curve for variable factor input or labor from this marginal condition. Now let us understand the graphical representation of profit maximizing condition. On x-axis, we take amount of labor available, and on y-axis, we take the wage rate. The demand curve for labor is given by the MRPL curve. Since we assume that labor market is perfectly competitive, the supply of labor to the individual firm is perfectly elastic, that is, the supply curve of labor SL faced by the firm is parallel to the horizontal axis. Now, for given wage W bar, the MRPL intersects the supply curve SL at point E and corresponding equilibrium level of labor L star. In imperfectly competitive commodity market, the MRPL is not the same as VMPL, that is value of marginal productivity of labor, as price does not equal to marginal revenue or marginal cost of labor. Since the price Py is greater than Mr, so the VMPL is also greater than MRPL. In case of more than one variable factor such as capital, in the long run, capital will also vary along with labor. The demand curve for labor will no longer be the simple MRPL curve. This is because when several factors are employed in the production simultaneously, a change in the price of one factor can alter the demand for the other factor and in turn shifts the marginal productivity curve of the factor whose price is changed initially. Now we will find the equilibrium level of output graphically corresponding to several variable factors. Assume that the firm produces output Y1 by using capital K1 and labor L1 when factor prices are R1 and W1 respectively. In the diagram, this is shown by the equality of the slope of the isoquant Y1 and the isocost line AB at point E1. Suppose that wage rate declines from initial rate W1 to W1 dash. This will rotate out the isocost line from AB to AC by pivoting around the point A, and the firm will produce more output Y2 at the level of capital and labor K2 and L2 respectively. This is shown by the new equilibrium point E2 in the figure. The journey from initial equilibrium point E1 to E2 can be divided into two effects, substitution effect and output effect. In order to explain these two effects more explicitly, we draw a new isocost line DF, which is parallel to AC and also tangential to the initial isoquant Y1, so that it shows the new factor price ratio and at the same time maintain initial level of production. The new isocost line DF is tangential to the isoquant Y1 at E1 dash. The movement from E1 to E1 dash happens due to the substitution effect. This implies that when wage rate falls, the firm substitutes more labor in place of relatively costlier capital. The firm increases the level of employment from OL1 to OL1 dash. Next, the movement from E1 dash to E2 is explained by output effect. The output effect arises because of the parallel shift of isocost line DF to the isocost line AC. It reflects the fact that at the same expenditure, the firm hires more of both capital and labor and is able to produce a large output. This is shown by the rise of labor from OL1 dash to OL2 and the increase in capital from OK1 dash to OK2. However, the story does not end here. There is another prominent effect, that is, profit maximizing effect, arising as the firm increases its expenditure in order to maximize profit. More intuitively, when wage rate falls, the marginal cost of production declines. This induces the firm to make additional expenditure for attaining the profit maximizing level output Y3. In the figure, this additional expenditure due to profit maximization is shown by the parallel upward shift of the isocost line AC to A-C'. The final equilibrium point is shown by the point E3, at which the new equilibrium level of output Y3 is obtained for corresponding OK3 level of capital and OL3 level of labor. We will see how substitution, output, and profit maximization effects help us to derive the labor demand curve. The substitution effect leads to a reduction in marginal productivity of labor as it substitutes more workers in place of capital, while the output effect and profit maximizing effect both have positive impact on the marginal productivity labor. This is because the employment of both the factor inputs, capital and labor, are raised by these two effects. Let us take labor on x-axis and wage on the y-axis. For different wage rates, we have corresponding level of employments by equating the wage lines with the separate MRPL curves. Suppose for three different wages rates W, W dash, and W double dash, we get three different equilibrium points E1, E2, and E3, and on the three separate MRPL curves. Thus, by joining E1, E2, and E3, we have the new demand curve for labor in case of several variable factors. Market demand for a factor. The market demand for variable factor by group of monopolists is simply the sum of the individual demands of those monopolists. Unlike perfectly competitive situation, there is no external effect of output expansion on price in imperfect market. There is internal effect of output expansion on price for each monopolist. When various monopolists use the variable factor, the market demand is the addition of the different component industry demand curves, where the industries may be formed by any number of firms. The derivation of market demand is the same for monopolistic competition and oligopoly. The individual demand curve for variable factors derived in case of monopolistic competition is the same as the individual monopolist's demand for factor, but when all firms in the product group expand output, there will be a fall in market price, like perfect competition. We can understand individual as well as market demand with the help of a diagram. The straight line DL in figure A shows the individual firm's demand curve for labor. Suppose at the wage rate W1, the firm is at point E1 and hires L1 units of labor. Assume that wage rate falls to W2. The firm moves from point E1 to E dash along the DL curve and increases its employment of labor from L1 to L dash units. Since all other firms behave in the same manner, the market supply of output increases and product price Py falls. This will result in a downward shift of VMPL curve or DL curve to the left. The firm is now at point E2 on the new demand curve for labor DL dash and hires OL2 units of labor at wage rate W2 in figure. Next, we see what happens in the market demand curve for labor, which is shown in the second panel of the figure. At the initial wage rate W1, aggregating all individual firms' demand for labor, we get a point E on the market demand curve for labor DL and corresponding OL1 units of aggregate level of employment of labor. At wage rate W2, each firm demands OL2 units of labor, and aggregating over all firms, the market demand for labor will be OL2 in figure B. By joining the points E1 and E2, we derived the market demand curve for labor as DL. Determination of equilibrium factor price wage. We are now in a position to determine the equilibrium factor price in the perfectly competitive factor market, while product market is imperfectly competitive by combining market demand curve and supply curve for variable factor labor derived in previous sections. Let us now graphically determine equilibrium factor price. On x-axis we have labor and on y-axis we have wage. In this model, individual labor supply curve is derived through the labor leisure choice of individual worker. The market supply curve is horizontal summation of individual labor supply curves. We can see the interaction between the market demand for labor DL and market supply of labor SL determine the equilibrium factor price W star corresponding to OL star level of employment of labor. In comparison with perfectly competitive firms, imperfectly competitive firms or monopolist firms always pay lower wage. The difference between VMPL and MRPL for a given level of employment is called monopolistic exploitation. Here, the gap between WC and WM represents the monopolistic exploitation for a given level of employment L star. Joan Robinson, The monopolistic exploitation is a situation in which a factor price is paid to any factor lower than its value of marginal productivity.